Hey guys, so tangents and normals is such a chapter which has got 14 marks weightage only in LAQs. That's distributed across two 7 marks questions, and it's very simple to get those 14 marks. So I want you to go through this lecture so that these 14 marks you can easily score them. Apart from these, tangents and normals has also got its weightage in VSAQs and SAQs, right? That apart, I'm only discussing the 7 marks questions. So all you need to do are around 8 to 10 questions, which will be mostly of the same standard and of the same ideas as well, so that you can easily score those 14 marks. So the first question that I'll be discussing is this one. So the tangent at any point P on the curve. So there's a curve that's given, and that tangent meets the coordinate axis in A and B. Okay. So there's a tangent. Tangent is nothing but a line. So I want you to imagine a line that's meeting the coordinate axis, because tangent is nothing but a line. Incidentally, according to this problem, the line is also nothing but the tangent, right? So I want you to imagine a line that is meeting the coordinate axis, right? The line also contains the point P. So can you imagine 3 points, A, which is on the x-axis, B, which is on the y-axis, and P, which is on that particular line. Is that clear? Right? So having that in mind, we need to find out the equation of the tangent. So for that, I need to have a point as well as a slope. So to find out any straight lines equation, I need to have a point as well as a slope. So let me imagine that let P be having the coordinates of h comma k. Okay, so P is denoted by h comma k. Now I have the points, the coordinates I have. Now I need to have the slope. So for that, slope is obtained by differentiating it. So basically slope is nothing but dy by dx, and I have the equation as x power n into y power n is nothing but a power n plus n. So I need to be using implicit differentiation because x and y are together, and when I differentiate this on both sides, differentiating on both sides with respect to x, right? I need to be using UV rule, and mind you, a is a constant, so the derivative of the RHS will simply become 0. So it is nothing but d by dx of x power m y power n is simply equal to 0, because a is a constant, a power anything will be a constant. So here I need to use UV rule. So x power m d by dx of y power n plus y power n d by dx of x power m, okay, has to be equal to 0. Proceeding further, I would be getting x power m. Since we are differentiating with respect to x, you need to use a composite function derivative. So n into y power n minus 1 into dy by dx. I'm sure you're following these. And then y power n into the derivative of x power m with respect to x only. So that's m x power m minus 1 is equal to 0. Clear? So simplifying this further, x power m into n into y power n minus 1 into dy by dx. I'm setting this term on the other side, giving me m y power n x power m minus 1. So what is that I need? I need the slope, which is nothing but dy by dx. From here, I will be subjecting, of course, there's a minus sign here, because when I send this here, this will be minus of the entire thing. So dy by dx, when I subject this, it will be nothing but minus m by n. This n I've cross multiplied. Y power n by y power n minus 1. This I've cross multiplied. And then x power m minus 1 by x power m. Okay. I've subjected dy by dx. On simplifying, I would be getting minus of m by n. So this goes y times and this goes x times, right? That is minus my by nx, which is the slope. Okay. So this is the slope of the tangent. Clear? Now I have the slope and I also have the point. Okay. So slope is minus m by n times y by x. Okay. And the point is h comma k. So slope at h comma k will simply be nothing but minus m by n times k by h, because all you need to do is to substitute h and k in the place of x and y, which on simplification will give me minus mk by nh. Is it clear, all of you? Now that being the slope and this is the point, I can write down the equation of the tangent. Okay, which is nothing but the slope point form y minus y1 is equal to m into x minus x1. Is it clear? So y minus y1 is nothing but k is equal to m, that is minus mk by nh into x minus h. This is the equation of the tangent. Clear? At this point, let me draw the figure that is corresponding to this. Okay, so will be somewhat like this. Okay, just a second. So I'll draw the y-axis, something like this, and then the x-axis, which would be something like this. Okay, sorry for that. Okay, so x-axis and y-axis, and the line would be somewhat like this. The point P is over here, which I'll call it to be h comma k. Okay, the point P is h comma k. This point will be A and this point would be B. Yeah, so A is nothing but a point on the x-axis, B is nothing but a point on the y-axis. So since A is a point on the x-axis, the y-coordinate should be 0, and similarly this should be 0. So let's try to find out what are the y-coordinate, what is the y-coordinate of B and x-coordinate of A. So for that, I will, in order to find out the x-coordinate of A, I will substitute y is equal to 0 over here, right? Replacing y is equal to 0, right? I would be getting minus k is equal to minus mk by nh, okay, into x minus h. So k gets cancelled. Of course, the minus sign also gets cancelled. So nh by m should be equal to x minus h, and x will be equal to nh by m plus h, which of course I can write it as h into n by m plus 1, right? So this coordinate will be given by this. Okay. Similarly, in order to find out the y coordinate of B, I need to substitute x is equal to 0, which will give me y minus k is equal to minus mk divided by nh into 0 minus h. So minus gets cancelled. Similarly, h gets cancelled. So y is equal to k plus, yeah, mk by n, which is nothing but k times of 1 plus m by n. Right? Now I have the values of both the coordinates of A and B. So A is represented by h of n by m plus 1 comma 0, and B is represented by 0 comma k of 1 plus m by n. Okay. Of course, having these two, I already have the value of P, which is nothing but h comma k. All I need to do is find out the ratio of PA is to PB. So let me first find out the distance PA. PA is nothing but y2 minus y1 whole square, k square, plus x2 minus x1, that is h minus of nh by m plus h whole square, which is of course PA square, which will give me k square plus, so this h gets cancelled, and n square h square by m square under root, that will be PA. Okay, that will be the value of PA. So what does that give me? I can write it as root over m square k square plus n square h square divided by m is the value of PA. Clear? Similarly, I'll find out PB square, which is nothing but the distance between these two. So x2 minus x1 whole square, which is simply h square, plus by the same logic, it will become mk square by n square. In fact, m square k square by n square, which gives me PB is equal to under root of, okay, under root of n square h square plus m square k square divided by n. So therefore, PA by PB is simply nothing but this by this, okay, which is root over m square k square plus n square h square by m whole divided by root over n square h square plus m square k square by n. So these two get cancelled. So PA by PB will simply be nothing but n by m, which is a constant, right? So that's what is asked to be proven, right? You need to just prove that PA by PB is simply nothing but a constant. Just check the question once again. Okay, this is what you need to do. It's just based on calculation. You need to be very careful. Very little part of it is differentiation and rest of it is purely calculation based. Okay, and then let's move on to the next question. So second question, if the tangent at any point on the curve so and so intersects the coordinate axis in A and B. Now this time a tangent to some other curve. So again it's a straight line. I want you to imagine a straight line meeting the coordinate axis in A and B, just like how we've discussed it in the previous problem. That length AB itself is a constant. So P is not a problem here, right? So now I want you to understand something called as parametric coordinates, right? So what I'll do is I'll take some point P, let any point P on the given curve be P of A cos cube theta, comma B, in fact, A sin cube theta. Okay, this is called as a parametric coordinate. Why is it called as a parametric coordinate? This theta is what we call it as a parameter, and we call these two as parametric coordinates. The reason is that when you substitute this here, irrespective of the value of theta, it will always satisfy. You might want to check it after the problem is done, right? You can just substitute this value over here, irrespective of what theta is. It will always satisfy the equation. That's the reason we call it the parametric coordinate in a parameter theta, and it can be treated as any point on this curve. Okay. Now again, we need to find out the tangent. For that, we have the point. I need to find out the slope, which is nothing but dy by dx. So I'll do the same thing like how I've done it for the first problem, differentiating on both sides with respect to x. That will give me d by dx of x to the power of 2 by 3 plus d by dx of y to the power of 2 by 3 is equal to 0. By now you understood as to why this is 0. Okay, because RHS is just a constant, has to be equal to 0. So 2 by 3 x to the power of 2 by 3 minus 1. Okay, nx power n minus 1, which I can directly write it as minus 1 by 3 plus 2 by 3 y to the power of minus 1 by 3. Since we are differentiating with a different variable, I'll have to include dy by dx, of course, equal to 0. 2 by 3 I'll take out common, which will get cancelled. So dy by dx, if I subject it, it is nothing but x to the power of minus 1 by 3 by y to the power of minus 1 by 3 with a minus sign. Okay. Because these two have negative powers, they can be reciprocated. So that will be nothing but y to the power of 1 by 3 by x to the power of 1 by 3. At which point are we trying to find out? Dy by dx at P is equal to. So here I have already taken the point P as a cos cube theta comma a sin cube theta. Okay, so the same point I will be substituting over here. So y is a sin cube theta and x is a cos cube theta, which will give me minus of a cos cube theta, in fact y is sin cube, a sin cube theta whole to the power of 1 by 3 by a cos cube theta whole to the power of 1 by 3, right? A power 1 by 3 and a power 1 by 3 gets cancelled. Sin cube to the power 1 by 3 is sin and cos cube to the power of 1 by 3 is cos. So that will be minus tan theta. That's the slope, right? So slope is minus tan theta and the point is already given. So equation of tangent is nothing but again y minus y1 is equal to slope into x minus x1. So what does that give us? Y minus a sin cube theta should be equal to minus tan theta into x minus a cos cube theta. Is it clear? So again, it's the same figure again. So that's your y-axis, that's your x-axis. Okay, there's a line AB, which is of course a tangent, whose equation we just found out is meeting the coordinate axis in A and B. So again, the coordinates of A will be something, comma 0, and here it will be 0, comma something. Okay, replacing x is equal to 0, or let's start with y is equal to 0 in order to get the coordinates of A. So give me minus A sine cube theta is equal to this tan theta. I will write it as sine theta by cos theta into x minus A cos cube theta. Okay, so one of these signs will get cancelled and that will become sine square. So that's in turn equal to minus A sine square theta cos theta after I cross multiply is equal to x plus x minus A cos cube theta. Clear? Then to find out the coordinate of x, I need x is equal to A cos cube theta minus A sine square theta cos theta. So I can take out an A common and I can also take out a cos theta common. So after I take out a cos theta common, I would be getting cos square theta minus sine square theta, which I can write it as A cos theta. This I already know it to be cos 2 theta. Therefore, the coordinates of A are A cos theta, comma, in fact, A cos theta, cos 2 theta, comma 0. Okay. Similarly, let's find out the coordinates of B by replacing x is equal to 0 in the same equation, right? In order to get the value of y. So that will give me y minus A sine cube theta is equal to minus sine theta by cos theta. Okay. In fact, we missed out this minus. Okay. Minus also gets cancelled. So that will give me A sine square theta after cross multiplying cos theta is equal to x minus A cos cube theta, right? And if I subject x, it is nothing but A into sine square theta cos theta plus A cos cube theta. And from these two, I can take out A cos theta common, and the leftover is sine square theta plus cos square theta, which is just 1. So that is A cos theta. Similarly, replacing x is equal to 0 in order to find out the value of the y coordinate of B, right? I would be getting, you can just write similarly, you need not write down the entire thing. Similarly, y coordinate will be equal to A sine theta. Okay, so now I have both the coordinates of A, which is nothing but A cos theta comma 0, and the coordinates of B will be nothing but 0 comma A sine theta. I need to find out the length of AB, which is nothing but root over A cos theta minus 0 whole square, that's A square cos square theta, plus 0 minus A sine theta whole square, that's A square sine square theta, which is simply equal to A. Therefore, AB is a constant. Fine. Let's move on to the next problem. Third problem. Similar model, right? If P and Q denotes the length of the perpendiculars drawn from the origin to the tangent and normal at a point respectively. So more or less similar model, right? So let the first few steps are just the same. Let P be denoted by A cos cube theta, comma A sine cube theta. Okay, these are the coordinates of P that are A cos cube theta, comma A sine cube theta. Got it? So I want you to do the same steps to find out the equation of the tangent. and of course few different steps to find out the equation of the normal. Okay, so first let us find out the slope is nothing but dy by dx, right? So for that I need to differentiate on both sides with respect to x, right? Which will give me 2 by 3 x to the power of 2 by 3 minus 1. The derivative of this is what I'm calculating, plus 2 by 3 y to the power of 2 by 3 minus 1 into dy by dx is equal to 0 because a is a constant, right? So dy by dx again will be nothing but minus y to the power of 1 by 3 by x to the power of 1 by 3. This is what, or this is the slope, right? So slope of tangent we knew it to be, we got it to be minus y to the power of 1 by 3 by x to the power of 1 by 3, which of course is nothing but, after I substitute this point, it will be minus a sine cube theta to the power of 1 by 3 by a cos cube theta to the power of 1 by 3. So a gets cancelled, which is nothing but minus tan theta. This is the slope of the tangent. So naturally, what will be the slope of the normal? It will be minus 1 by the slope of the tangent, which is minus 1 by minus tan theta, which is of course cot theta, right? So I have the slope of the tangent and I also have the slope of the normal. With these two slopes, I also have the point at which I need to find out the equations of tangents and normals. So a cos cube theta comma a sine cube theta is the point. So let me find out the equation of tangent. Okay, equation of the tangent. Just done it in the previous problem itself. So y minus y1, that is a sine cube theta, is equal to minus tan theta into x minus a cos cube theta. Fine. So I'll just rearrange these to write it as y minus a sine cube theta is equal to sine theta by cos theta. This minus I'll send it inside and write it as a cos cube theta minus x tan theta. In fact, minus x because tan theta is still outside. Okay. So just cross multiply this, which will give me y cos theta minus a sine cube theta cos theta is equal to a sine theta cos cube theta minus x sine theta. Further rearranging, I'll bring all the terms onto the LHS, all the x and y terms onto the LHS and all these theta terms onto the RHS. So this, if I bring it here, x sine theta plus y cos theta is equal to, sending this over here, I can also take out things common after sending this here. That's a sine theta cos theta into sine square theta plus cos square theta, which is of course 1. So the equation of tangent is nothing but x sine theta plus y cos theta is equal to a sine theta cos theta. Okay, equation of the tangent. Similarly, I'll find out the equation of normal, right? So this, let's call it to be the equation of tangent. Okay, equation of normal, same, y minus y1 is equal to slope of normal. We just found it to be cot theta into x minus a cos cube theta. Okay, right? So further nothing but y minus a sine cube theta is equal to cos theta by sine theta into x minus a cos cube theta. Cross multiplying, I would be getting y into sine theta minus a sine power 4 theta is equal to x into cos theta minus a cos power 4 theta. Okay, so again rearranging, I'll bring all the terms, all the x and y terms onto the RHS and then write it to the left. X cos theta minus y sine theta is equal to, if I bring this here, I would be getting a into cos power 4 theta minus sine power 4 theta. So x cos theta minus y sine theta is equal to a into cos square theta plus sine square theta into cos square theta minus sine square theta. Okay, that's one again, which is nothing but x cos theta minus y sine theta is equal to a into cos square theta minus sine square theta is nothing but cos 2 theta. Okay, this is your equation of the normal, right? So now let us go back to the question and read what it exactly asks. if P and Q denotes the length of the perpendiculars drawn from the origin, the tangent and normal. So I have the equations of tangents and normal, right? So I have to find out the length of the perpendicular P, which is given by the length of the perpendicular from 0, 0 to the tangent, right? I already have the tangent equation. I'm sure you remember the length of the perpendicular formula. Okay, from x1 comma y1, if I want to find the length of the perpendicular from ax plus by plus c equal to 0, then it is mod of ax1 plus by1 plus c divided by root over a square plus b square. Okay, so let's find this. You need not write. I just shown it to you to understand what formula I'm going to use, right? So now length of the perpendicular from 0, 0 onto the tangent, whose equation I already have, that is x sine theta plus y cos theta is equal to a sine theta cos theta. The tangent whose equation is given by x sine theta plus y cos theta is equal to a sine theta cos theta, or further you can write it as minus this is equal to 0. So the form ax plus by plus c, right, from 0, 0. So modulus of sine theta into 0 plus cos theta into 0 minus a sine theta cos theta divided by root over a square plus b square sine square theta plus cos square theta, that is p. Okay, so what exactly is p? It is nothing but modulus of a sine theta cos theta, and I will try to find out p square, which is a square sine square theta cos square theta, and then I'll try to find out 4p square, because that's what is there in the question. 4p square is nothing but a square, in fact 4a square sine square theta cos square theta. So these three will be together called as a square sine square 2 theta. Okay, similarly q is nothing but the length of the tangent, in fact length of the perpendicular from 0, 0 to the normal. And what is the equation of the normal? It is x cos theta minus y sin theta minus a cos 2 theta is equal to 0. So applying the same thing, q will be nothing but modulus of minus a cos 2 theta. Okay, and what is q square? It will be a square cos square 2 theta. And you're supposed to find out 4p square plus q square, which is nothing but a square sine square 2 theta plus a square cos square 2 theta, which is simply equal to a square, right? Therefore, that's the final result, that is 4p square plus q square is equal to a square. So these are the three lengthy problems that you will be having in this particular chapter, whereas the next few problems will not be this lengthy. Okay, let's move on to the next problem. Show that the equation of the tangent at a point x1 comma y1 is so and so. Quite a simple problem. Okay, not even that lengthy. This is your fourth problem. So all you need to do is to find out the slope, because you already have the point here. You need to find out the slope. So in order to find out the slope, again it is nothing but dy by dx. What I want you to observe is, for all these problems the methodology is just the same. It's the challenge is only the calculation, right? Let's do it here. Root x. Okay, so first I will be differentiating on both sides. So root x plus root y is equal to d by dx of root a, which of course is anyway a constant, right? So now derivative of root x is 1 by 2 root x, right? Derivative of root y is 1 by 2 root y dy by dx. Derivative of this is 0. So 2 gets cancelled. Dy by dx, if you subject it, it is nothing but minus the root of y by x. Okay, you have the derivative, which is the slope, of course, and you have the point, okay, which is x1 comma y1. So I need the derivative at x1 comma y1, okay, which is nothing but minus root over y1 by x1. Okay, so equation of tangent will be nothing but y minus y1 is equal to, right, m, that is minus root over y1 by x1 into x minus x1. Clear? So when you simplify this further, you just have to cross multiply this to get, or let me cross multiply this to get y root x1 minus y1 root x1 is equal to this minus. I'll send it inside, so this will be reversed. Okay, x1 root y1 minus x root y1. Got it? So in order to get to what is exactly asked, what I'll do is I'll divide on both sides, right? Divide on both sides by root x1 y1. Okay, I'll divide on both sides by root x1 y1, which will give me, in fact, before doing this step, I'll just do a small rearrangement of the terms. Okay, just a second. I'll just rearrange the terms by a little bit before I do this. Okay, so I'll just rearrange the terms by bringing this over here and sending this onto the RHS, which will give me x root y1, okay, plus y root x1 is equal to, this part is nothing but root x1 y1 plus x1 root y1. From these two, of course, I can take out root x1 y1 common, and then I'm left with, right, root x1 plus root y1. But since the point x1 comma y1, I want you to write this step, since the point x1 comma y1 lies on the curve root x plus root y is equal to root a, this should be satisfied by root x1, this should be satisfied by x1 and y1. Okay, so by doing so, just a second. Right, I'll just postpone this step for a moment. So by doing so, I get root x1 plus root y1 should be equal to root a, which I'll substitute over here, which will give me x root y1 plus y root x1 is equal to root x1 y1 into root a. Now I'll divide on both sides by root x1 y1, which will give me x root y1 by root x1 y1 plus y root x1 by root x1 y1 is equal to root a. Okay, so this gets cancelled. Similarly, this gets cancelled. So x by root x1 plus y by root y1 is equal to root a, which you can write it as per the question. That's x power minus 1 by 2 plus y power minus 1 by 2 is equal to a power 1 by 2, which is what the question asks to prove. Clear? This is a simpler problem relatively. It's just a little bit of calculation involved. Let me move on to the next problem. Again, quite a simple problem. Show that the curves y square equal to so and so and y square equal to so and so intersect orthogonally. So for this, you need to know the word orthogonality, right? The word orthogonally means, it's just a fancy word for perpendicularity. So all you need to do is show that the curves so and so and so and so intersect perpendicularly, right? So that means their slopes should be of the form m1 m2 equal to minus 1. The slopes should be the product of the slopes should be minus 1. For that, let me first find out where are they meeting. If I find out where they are meeting, right, that should be the first step. So in order to find out where they are meeting, I should be equating this and this because both of them are y squares. So y square, which is equal to 4x plus 4, after I send 4 here, is equal to, right, in fact I can keep that 4 outside because anyway it's going to get cancelled, is equal to 36 of 9 minus x, goes 9 times. So x plus 1 is equal to 81 minus 9x. So 10x is 80, x is equal to 8. Okay. So now that I got x is equal to 8, let me find out what is the point on this, which is nothing but y square is equal to 4 into 8 plus 1, that is equal to 36. So y is equal to plus or minus 9, in fact plus or minus 6. Similar, so this is when I substitute it over here, and when I substitute it over here, I would be getting y square equal to 36 into 9 minus 1, which is equal to 36 into 1. So y will be equal to plus or minus 6 again. So these two curves are meeting each other. Let us say the curves are somewhat like this. The curves are meeting each other at 2 points. The first point is 8 comma 6 and the second point is 8 comma minus 6, which is what we identified. Okay, so you need to find out the slope of curve 1, right? How do you find out the slope of curve 1? The equation is y square is equal to 4 into x plus 1. So for that, I need to find out the derivative, which is 2y dy by dx is equal to 4. 4x derivative is 4, 4's derivative is 0, right? So dy by dx is 2 by y, which is nothing but 2 by 6, which is of course equal to 1 by 3. Okay? Slope of curve 2. Okay, what is curve 2? Y square is equal to 36 into 9 minus x, right? So again 2y dy by dx is equal to 36 into 9's derivative is 0, and then that is minus 36. So dy by dx is nothing but minus 18 by 2y, nothing but minus 18 by 2 into 6, which is of course equal to, let me just check, 2 gets cancelled and then you're left with 36. Okay, so basically this is 36. I'm sorry for that mistake. This is 36. Okay, so that will be minus 3. Therefore, slope of curve 1, let's call it to be m1 and m2, equal to m1, and this is equal to m2. So m1 into m2 should be equal to 1 by 3 into minus 3, which is equal to minus 1. Therefore, they intersect orthogonally, right? You might have had a doubt as to why I have only taken plus 6. You can also do it using minus 6. You'll still end up with the same answer. Okay? That's it, because the product of slopes is minus 1. They intersect each other orthogonally. All right? Now, show that the curves so and so and so and so touch each other at 1 by 2 comma 1 by 2. Touch ante entante they are meeting tangentially like this, right? If two curves are behaving like this, then we say that they are touching each other. But if two curves are behaving like this, then we say that they are intersecting each other, right? So this is the case that we are talking about. This happens when the slope of this curve at the given point is equal to the slope of this curve at the given point. Okay, so first let us find out the slope of curve 1. How do you find out? Again by dy by dx. Okay, so let me differentiate on both sides. That's 12x minus 5 plus 2 dy by dx is equal to 0, or in other words dy by dx is equal to 5 minus 12x by 2, right? So slope of curve 1 at 1 by 2 comma 1 by 2 is what you need to find out. Okay, so that is equal to 5 plus 12 into 1, in fact 5 minus 12 into 1 by 2, 5 minus 12 into 1 by 2 by 2, which is nothing but 5 minus 6 by 2, which is minus 1 by 2. Okay, similarly slope of curve 2. So to find out curve 2 slope, again I'll have to differentiate it on both sides with respect to x. So differentiating, I'd be getting 8x plus 16y dy by dx is equal to 0. Okay, let me do that. 8x plus 16y dy by dx is equal to 0. 8 gets cancelled. X plus 2y dy by dx is 0, or dy by dx is nothing but minus x by 2y. Okay, slope of curve 2 at 1 by 2 comma 1 by 2 is equal to minus of 1 by 2 by 2 of 1 by 2, which is also equal to minus 1 by 2. Okay, so what do you see? Slope of the first curve is exactly the same as the slope of the second curve, right? Therefore, slopes of both the curves at the given point are equal, which implies they touch each other. Okay? Right? Then next problem again on orthogonality, again a quite a simple problem. Okay? Show that the condition for orthogonality, so these are the two curves, if they are meeting orthogonally, show that the condition is so and so. Again, quite a simple problem. So if they are meeting somewhere, let's call that let the point of intersection, let the point of intersection be some h comma k again, right? So since h comma k is lying on this as well as on this, right? Since h comma k lies on curve 1, let's call this to be curve 1 and let's call this to be curve 2. Okay, h comma k should satisfy this, ante ah square plus bk square should be equal to 1. Similarly, since h comma k lies on curve 2, right, it should satisfy this equation also, which is a1 h square plus b1 k square should also be equal to 1. I'll call this equation 1 and I'll call this equation 2. Okay, just before I proceed with the problem, let me simplify it by doing equation 2 minus equation 1. What does that give me? H square into a1 minus a plus k square into b1 minus b should be equal to 0. Right? Call this equation number 3, which will be useful in the next few steps. Right? Now, condition for orthogonality, that happens when the slope of this into the slope of this should be equal to -1. So first let us find out the slope of curve 1. Okay, that is ax square plus by square is equal to 1. So for that I need to differentiate on both sides. 2ax plus 2by dy by dx equal to 0. 2 gets cancelled. Dy by dx is minus ax by by at h comma k. Slope of curve 1 is minus ah by bk. All right. Similarly, slope of curve 2, I need to find out the derivative, that is 2a1x plus 2b1y dy by dx. I'll equate that to 0. Okay, so dy by dx is nothing but a1x by b1y with a minus sign at the same point h comma k. So slope of curve 2 is minus a1h by b1k. Right? Sorry, a1h by b1k. Okay, since curve 1 and curve 2 are orthogonal, right, product of slopes should be equal to -1, which means ah by bk with a minus sign minus a1h by b1k should be equal to -1. So minus into minus will make it plus. So that's h into, in fact, h square into aa1 by k square into bb1 should be equal to -1. Okay. So cross multiplying and also bringing it here, h square into aa1 plus k square into bb1 should be equal to 0. But from equation 3, which we have derived, okay, from equation 3, let's just go back to check what equation 3 is. Okay, this is the equation 3 that we have. Can I subject h square from this and write it as, in fact, let me first write down equation 1 here, that h square into a1 minus a, okay, a1 minus a plus k square into b1 minus b is equal to 0. Fine. So h square is nothing but b1 minus b into k square with a minus sign divided by a1 minus a. Okay. So this h square I'll substitute it over here. to get A1 into minus B1 minus B divided by A1 minus A into K square plus K square into B1 should be equal to 0. So both of these have a K square common, which I'll send it on the other side. Okay. And then I have A1 into B1 minus B, I'm sending everything over here, is equal to B1 into A1 minus A. Okay. And then I'll divide on both sides. Divide on both sides by A1, B1, AB, which will give me, right, A1 into B1 minus B by A1, B1, AB is equal to B1 into A1 minus A by A1, B1, AB. So BB1, BB1, AA1, AA1 gets cancelled. And after I divide each term, B1 by BB1 is 1 by B minus 1 by B1 is equal to 1 by A, right, minus 1 by A1. Okay, you can rearrange the terms to get what is exactly asked. Let me just go back to see what is exactly asked. 1 by A minus 1 by B is equal to 1 by A1 minus 1 by B1. So all you need to do is to rearrange the terms, bring this here and then bring this here. 1 by A minus 1 by B is equal to 1 by A1 minus 1 by B1. Right? That's your final result. Next problem. Find the angle between the curves. Let me do the first bit here. Find the angle between the curves. 2y square minus 9x is equal to 0 and 3x square plus 4y is equal to 0. So in order to find out the angle, I first need to find out where they are meeting. So for that, I will just write this equation. 2y square minus 9x is 0, which means x is equal to 2y square by 9, which I'm going to substitute here. That's 3 into 4y to the power of 4 divided by 81 plus 4y, of course, is equal to 0. So 4 gets cancelled, goes 27 times. So y power 4 plus 27y is equal to 0. I take out y common. Y cube plus 27 is equal to 0. So either y is 0 or y cube is minus 27. So y cube minus 27 and y will be equal to minus 3. And of course, y is 0. But I won't accept this because it is clearly mentioned that we are talking about the fourth quadrant. So this y I'll substitute it over here to get the value of x as 2 into 9 by 9, which is equal to 2. Therefore, the curves intersect at 2 comma minus 3, which is obviously in the fourth quadrant. Okay. At this point, I'll find the slope of the first curve and then I'll find out the slope of the second curve. Okay. So slope of 2y square minus 9x equal to 0. How do you find it out? 4y dy by dx minus 9 equal to 0. So dy by dx is 9 by 4y. At which point? At 2 comma minus 3. So that is 9 by 4 into minus 3, which is equal to minus 3 by 4. Slope of the first curve. Right? What about the slope of the second curve? Again, 3x square plus 4y is equal to 0. So I'll have to differentiate it. Slope of 3x square plus 4y equal to 0, giving me 6x plus 4 dy by dx is equal to 0. Further, dy by dx is nothing but minus 6x by 4, which is minus 3 by 2 into x. At which point? At 2 comma minus 3. So I'll put x is equal to 2. So that is minus 3 by 2 into 2 is equal to minus 3. Right? So I have slopes. I need to find out the angle between them. How do you find out? So tan theta is equal to modulus of m1 minus m2 by 1 plus m1 m2. Okay, I'm sure you can finish it off from here. Same logic for the second problem as well. All right, just the same logic for the next bit as well. Okay. So your next problem, At any point t on the curve, x is equal to so and so and y is equal to so and so, find the lengths of tangent, normal, subtangent and subnormal. Okay. So you need to find out the lengths of tangents, normals, subtangents and subnormals. So first thing I need to do is to find out the derivative dy by dx. But here it's not direct. You need to use parametric differentiation by writing it as dy by dt by dx by dt. Okay. So dy by dt is nothing but derivative of d by dt of a minus a cos t, which is equal to a sin t. By now you're all confident with differentiation, I'm sure. Dx by dt is nothing but d by dt of at plus a sin t, which is nothing but a plus a cos t. Okay. Therefore dy by dx is simply equal to this divided by this, ante a sin t by a into 1 plus cos t. I'll just simplify this further before I proceed. Sin t can be written as 2 sin t by 2 cos t by 2 by 1 plus cos t can be written as 2 cos square t by 2. So 2 gets cancelled, one of the cos gets cancelled. So that's tan t by 2. Okay. So we ended up getting the slope as tan t by 2. Okay. That's your slope. And you also have your y coordinate, which is nothing but a into 1 minus cos t. So y coordinate will be a into 2 sine square t by 2. I brought it into submultiple angles because this is also in terms of submultiple angles. Okay. So what is the length of the tangent? Length of the tangent is equal to y by m root over 1 plus m square. That is equal to a into 2, of course, right? Sine square t by 2 by m, that is tan t by 2 into root over 1 plus tan square t by 2, which is 2a sine square t by 2 by sine t by 2 by cos t by 2, which I'll write it here, into this part is nothing but 1 plus tan square t by 2 is secant square t by 2 under root is secant t by 2. So cos t by 2 secant t by 2 is 1. Gets cancelled. That's 2a sine t by 2, the length of the tangent. Similarly, you can find out the length of the normal, which is equal to y1 root 1 plus m square, right? So this part won't be there. So that's 2a sine square t by 2 into root over 1 plus tan square t by 2, which is of course equal to 2a sine t by 2, in fact sine square t by 2 into secant t by 2. Just to simplify it a little further, that's 2a sine t by 2 into sine t by 2 into 1 by cos t by 2. Sine square ka this, so sine t by 2 into sine t by 2 into 1 by cos t by 2, which you can write it as sine t by 2 tan t by 2. Right? Length of subtangent is nothing but y1 by m, which is of course 2a. Y1 is 2a, right? That is, let me just check that, sine square t by 2 by tan t by 2. You can just simplify it by writing it as 2a sine t by 2 sine t by 2 by sine t by 2 by cos t by 2. Sine t by 2 gets cancelled. When I take cos t by 2 here, that will give you 2a sine t by 2 cos t by 2. 2 this and this will give you a sine t. Okay. And then length of the subnormal is equal to y1 into m, is of course equal to 2a sine square t by 2 into tan t by 2. There's nothing much to simplify over here. Okay, these are the 4 things that we're asked to find out. Got it? Then the last problem, which is also similar to what you've done, but all you need to find out are only subtangent and subnormal. Let's do that. So again, for that you need to find out m, which is dy by dx, which you can find it out by parametric differentiation dy by dt by dx by dt. Okay, dy by dt by dx by dt. So dy by dt is nothing but derivative of d by dt of a sin t minus at cos t. Okay, a is a constant, derivative of sin t is cos t minus derivative of t cos t. By using UV rule, will give you cos t into 1 plus t into minus sin t. Okay, so this cos t gets cancelled, so you are left with at sin t, because there's a minus here, another minus here, so minus into minus will give you a plus. At sin t is the derivative of y with respect to t. And what about dx by dt? It is again nothing but d by dt of a sin t minus at cos t. I'm sorry, this is y, so x will be a cos t plus at sin t. Okay, so that will give you derivative of cos t will be minus sin t plus a t sin t. The derivative of t sin t is again done by UV rule. So t cos t plus sin t into 1. So a sin t and a sin t will get cancelled and you're left with a t cos t. Right? Therefore, the slope is dy by dt by dx by dt, which is nothing but at sin t by at cos t, which is of course equal to tan t. Right? So you're supposed to find out the length of subtangent, which is y by m. Okay, y by m is simply nothing but, so let's check what are asked. Yeah, y is this, and then by tan t, which is in turn equal to a into, right? Let me just check what is y, sin t minus t cos t. That's a into sin t minus t cos t by tan t, which is length of subtangent. And what about length of subnormal? Is equal to y into m, which is a into t cos t. Let me just check that again. Cos t plus t sin t by, sorry, into tan t. Okay, t sin t into tan t. Right? So with these problems, around 9 of them, right, if you practice these thoroughly and write down all the steps, I'm sure you would be getting these 14 marks easily. All right, thank you so much.